Alright, today's lesson is writing equations of lines. This is going to go further into the different forms you'll see and how to navigate them. The first one's slope-intercept form, also SIF, you'll see on your worksheets if we have that. That form you should be familiar with. That is just y is equal to mx plus b, where m is equal to the slope and b is equal to the y-intercept. And that gives you the point 0, comma b. Okay. This next form is the most important one, I think, because you always start with it. So this is really what happens when you solve. You do this one first, go to that one, and then finish with standard. What's nice about this one is you don't need the y-intercept, you just need a point. Okay? So this is y minus the y-coordinate of the point equals the slope times the x-coordinate, times x minus the x-coordinate of the point. Notice how the signs are opposite of what they really are. In this one, m is still the slope, but the point is x1, comma y1. That's it for point slope form. So, just remember that it's the opposite sign. Now, standard form is ax plus by equals c. And I wrote 0. This one people get confused with because they try to put it in this form immediately. You can't do that. You have to manipulate slope intercept form or point slope form to get it to this. So if it says write it in standard form, you still have to go through all the work. It's a lot easier to do it that way. The rules for standard form: a, b, and c must be integers. Can't have fractions. And then a must always be positive. Okay? So let's see how we can do that with these problems. The first one says write the equation of the line that contains these 2 points in point slope form, slope intercept form, and standard form. So I'm going to start with point slope form. We have a point, we have 2 points actually, so we can use either or. So I'm going to use this point when we get there. But I need a slope. So the first step you should always do is get that slope. So y2, which is 5 minus y1, which is 2, over 6 minus 1, you get 3 over 5 is the slope. Okay? Now we can write point slope form out. It's just, I'm going to use this point right here. It's y minus that point, so it's 2 equals 3/5 x minus the x-coordinate, which is 1. That's my final answer. That's why you start with point slope form. You just plug it right in. Now we can go from point slope form and start working to slope intercept form. To do that, you solve for y. So I have y minus 2 is equal to, I'm distributing 3/5 x minus 3/5. If I add 2 to the other side, I get y is equal to 3/5 x plus 7/5. And sure enough, this is now in slope-intercept form. Finally, we take slope-intercept form and we rearrange it so that the x's and y's are on the same side. So the first thing I'm going to do is move the x's over, negative 3/5 x with that positive y equals 7/5. Okay, but we cannot, the rules state that all these have to be numbers, no fractions. Integers, so we have to have integers, and that this first thing has to be positive. So I'm going to multiply everything by negative 5. So negative 5 times negative 3 is 15 over 5 is 3x minus 5y equals negative 7 when you do the multiplication. This is now standard form. All 3 numbers are integers, and the first one is positive, so we are done. So again, point slope to slope intercept to standard. That's how you go. Alright, let's do another one, except for we don't have to do all of them. We just have to get to slope intercept form for this problem. Now when it says stuff like it's parallel to this other graph, that means you go to the other graph equation first and find its slope. What's nice about this one is it's already in y equal form, so we know that the slope of this one is equal to 2/5. So that means our other line has to be parallel to that. So that means the slope we're going to use is also 2/5. And the point we're going to use is 4, -2. So I'm going to start off in point slope form. Y minus a -2 makes it a +2 equals the slope times x minus the x coordinate, which is 4. However, am I done? Double check. No, I need slope-intercept. That means I need to solve. So that's where I go this way, and I distribute on the one side. And this becomes -8/5. And then we can move the 2 over by subtraction, and we get our slope-intercept form of y is equal to 2/5 x minus 18/5 if you plug that into your calculator. So that is my final answer. It does still have the, so we know they're parallel because the slopes match, and it's in slope-intercept form. Okay, next page, we're going to do the same thing. We're going to write an equation on the line that contains this point. So this is the point we're going to use, and it's perpendicular to this line. So first of all, and we have to get into standard form, so this is actually going to be a little bit of work. First off, we need to know what the slope is of this equation, and you can't do that just by looking at standard form. So we have to solve it for y. So we get 4y is equal to -3x plus 120. We get y is equal to -3/4 x plus 30, which doesn't really matter. So the slope of this line is 3/4, -3/4 I should say, but I don't want that. I want perpendicular. So the perpendicular slope, you flip it and change the sign, is +4/3. This is the slope I'm going to be using with this point. Now we do the whole thing. We start with point slope form, and we just write it out. Y opposite of that point, which is +5, is equal to our perpendicular slope, x plus 1. That's that. I need to get to standard form, so I am going to manipulate this a bit. You don't have to stop at slope-intercept form. We're just going to, I mean, we'll probably get it into slope-intercept form, but we don't have to stop and box that. We get, this is slope-intercept form, so 4/3 minus 5 is a -11/3. So now, remember, this is slope-intercept form, but I need to keep going. Standard form, get the x's and y's over together. So we get -4/3 x plus y equals -11/3. Multiply again by a -3 to cancel out the bottoms. -3 times -4 is 12/3 is 4x. This becomes -3y, and this becomes 11. So this would be standard form that is perpendicular to the slope of -3/4. Okay, one more of these. This is a special case because it's a horizontal line. Horizontal line, you should recognize, is just y equals and then whatever y equals. Y equals this, x will be everything, y equals 0.95. Now you can do two things. You need to get rid of the decimal because we need it in standard form. So you can just multiply by 100 and you get 100y equals 95. And that would be in standard form. If there's no x value, you're done. Or if you turn this into a smaller fraction, you could make it, you can divide both sides by 5 and you can make it 20y is equal to 19. Either of those work. Okay? Alright, the last two problems are word problems. Now, when you do word problems, it's important to understand which one your x and y is. Okay, usually it's something y in terms of x, the output in terms of the input. So when you read the question, we have airline fares of $201 for 386 miles, so we have dollars and miles, and then a slope increase is 0.138 per mile. So this kind of tells you actually what is your y and your x, because slope is y over x. So this is dollars per mile. So the dollars, the rate, the airfare is going to be your y. The miles, or the distance, is going to be equal to your x. And actually this is going to be time of flight, so number of miles t of the flight. So we're actually using t instead of d. So we have a and t. A is y, t is x. So we can write our points as our point. We know that when our distance is 386 miles, it costs $201. We also know that the slope is equal to $0.138 per mile. So I can go right to point slope form and say that our value is A minus the amount for this flight that we're using is 201 is equal to the slope times t, the distance traveled of the flight, total miles of the flight, minus 386. So again, I just did what I did up there. I used point slope form. I had a slope and a point, but with words, and I plugged it in. This is y, this is x. We solve because it's easier to work with these kind of equations when it's y equals. That would you multiply? You get 53.268. And then finally you get a is equal to, when you add 0.138t plus 147.732. So that's the model telling you how much it is, the ticket, based on how many miles you fly. So let's look at this last part. It says estimate the airfare A if you go from Boston all the way to San Francisco, which is 2629 miles. It's 2,629. So we're going to just plug that in for our t. We want to know how much it costs when we fly 2,629. And you estimate that the cost of that ticket would be about $510.53. And that's how you do a linear problem with words. Again, identify y and x and your units. Okay, last problem about cats. In 2008, there were 57 million cats as pets in the United States. By 2015, this number was 61 million. Write a linear model for the number of cats as pets. Use it to predict for 2027. Now here's the key, guys. Let t equals 0 represent the number of years since 2008. So they're saying that instead of using the number 2008, use 0. So we have 2 points then. Again, this is going to be years and then number of cats. So cats are y, and x, or time is x. So we have 2 points. We know at 2008, which is 0, there were 57 million cats. And we know that 7 years later, so 2015 would be represented by 7, we have 61 million. So we can find the slope of that, and that would be just 4 over 7. And what that means is it goes up by 4 million cats every 7 years. Okay? Which makes sense because that's what it did for the first 7 years. Now you can use point slope form, or actually you can use slope intercept form because that's actually an intercept because it's 0, comma. But I'm going to just keep using point slope form. Cats minus there were 57 million. Equals the slope of how it's changing, and then t minus 0. So we get our model, the number of cats per year is equal to 4/7 t plus 57. So there's our model, and now we can estimate 2027. Well, from 2008 to 2027, that's 19 years. So now I'm going to put a 19 in. And you get that, you get 67.857 million cats. That's a lot of cats. Okay. So 67.857 million cats. So that's using, again, just a linear function, but understanding you need to get points and a slope out of the data or the information and understand which one your x and y is. That's the hardest part of the word problems. Otherwise, it's just the same thing you were doing. Okay, that would be it for today. I will see you guys later.